I'm going to be demonstrating how to use the evaluations for the AI gene review system. The URL for this can be found at ai4curation.io/ai-gene-review. There is some documentation here. There's a set of guidelines for the evaluation form, which you can read, and a set of guidelines for the voting system here with all of these different categories. But let me just walk you through the system. Basic idea is you can go to the annotation browser here, and here we can review we can look at the reviews that the AI has performed on existing Go annotations. These are all categorized according to the action under which the AI classified the annotation. So many of these are classified as accepts. This means that the AI was happy with the existing annotation as is, but the AI has also classified some annotations into different categories. This is a faceted browser, so you can do your query by a number of different facets. You can query by the gene symbol, you can query by species, so we can narrow our set of terms down based on species, based on evidence code. But maybe the fastest way in is if you just do a search for your gene of interest, and it will narrow it down here. So here we have done a search on the CFAP300 gene. You can use this to browse all of the individual annotations for this gene, but what I recommend you do is you simply click on a review to look at the review itself, and then we'll walk through how you go about giving your evaluation of this review. So the first thing to note is that there's essentially two evaluation mechanisms. One, we'll walk through this in a moment, but you can click on this big green button that will take you to a form where you can provide detailed evaluation feedback. But there's also a lightweight evaluation system where you can simply give thumbs up and thumbs down on various pieces of information and actions that the AI has curated. So let's walk through this. So this is the CFAP300 gene. We can always click on this to look at the corresponding UniProt or SwissProt entry. And you can see annotations, functions, subcellular localizations, and so on here. But we'll focus our attention here on the AI gene review. So you're able to give lightweight thumbs up, thumbs down votes on basically anything that the AI has generated. So you, if you see these, this means the AI has generated this. So it's generated a gene description here. If you think this is a good gene description for this gene or this protein, you can simply click thumbs up, thumbs down, and this part of the voting is anonymous. Now we can go down and look at the individual reviews of each individual annotation. So let's take a look at the first one. So we're going to walk quite carefully through the four different columns here and what each one of these mean. So the first two, the Go term and the evidence, these are derived from the existing Go annotations here. So there is an existing Go annotation to protein binding with the IPI evidence, and you can go and read the publication if you like. Now, it's very critical to realize we're not voting here on the original annotations. We're voting on the AI review. And so the AI review is in these second two columns, action and reason. So in this particular case, the AI has decided that the particular action for the protein binding annotation for CFAP300 should be modify. What does modify mean? Well, modify means the annotation is not inherently wrong, but based on this, this publication, the AI believes that it should be replaced with a different or more specific term. In this case, protein macromolecule adapter activity. You can click on this if you want to see more details of the Go code. And you can also look at the reason the AI has given for this proposed modification. So it's given you a summary here. It's given us a reason that this publication states this particular piece of information. Protein binding's uninformative. CFAP 300, functions as an adapter scaffolding protein for dynein arm assembly. And you can see it's also given you the particular snippet of text from this publication here. So if we agree with the AI's proposed actions, and again, we're not voting on the original annotation, we are voting on the review. So if we agree with the AI actions that we prefer protein binding to be replaced with this term, we would click thumbs up. And this is circled already because I've already selected this. So moving on, in the second case, the AI believes that there was an original annotation, that this is localized in the cytoplasm based on an ISS code, so a manually reviewed sequence similarity. In this particular case, the AI agrees with this and says, let's just accept this. So if we agree with both the AI and the original annotation, we give thumbs up. If we were to disagree with either the original annotation or the review, we can do thumbs down here, and so on. Cytoskeleton, in this case, it's also suggested to modify this. It's not inherently wrong, but it's too general, and it thinks that this should be replaced by axoneme. If we agree with this proposed modification, thumbs up. If we either disagree with the modification and we think the original annotation is correct, or we might also disagree with the original annotation, but also think the modification is incorrect. In either of those cases, you would give the thumbs down. And again, this part of the voting system is intended to be lightweight and anonymous, and so on and so on. You can see the different categories here, and in each case, the AI will always provide some kind of explanation and the reasoning. And if you disagree, even if you agree with the call, in this case, say to remove cell projection, but if you think that the reasoning is somehow faulty or just problematic in some way, feel free to just give this a thumbs down if you disagree with it, and so on. And depending on the gene, there may be like a handful of these. There may, in some for well-studied genes like P53, there may be like hundreds and hundreds of these. You should not feel compelled to give thumbs up and thumbs down on everything. You can simply kind of like select the ones that you care about. Now, this optionally, you can go into the second section here, where the AI is essentially try to figure out a way to essentially kind of summarize the core functions of this gene. So it's given you essentially a text summary of its core function, cytoplasmic assembly and intracellular transport of axonemal dynein arms, and it's essentially made a little Anaton-like unit here with a function. This function is involved in these processes in these locations with these substrates. If we agree with this in totality, we can do thumbs up. If we disagree with any part of it, we can do thumbs down. And it's given us the supporting evidence here. We've got a long list of references here, including a deep research summary. In each case, there's a little AI summary of each of the publications. Then further down here, you can see the AI, some suggested questions for experts here. If you think this is a good question, you can give a thumbs up here. If you think it's a bad or stupid question to ask an expert, you can give a thumbs down. Similarly, it's also suggested some experiments that could be done to further elucidate the function. And again, if you think this is something is kind of like useful or pointless, or you would give the thumbs down, but if you like it, give the thumbs up. Optionally, you can go deeper still, and you can look into some of the additional products that were generated to make this AI review. One of the key ones here is what's called the deep research summary. So we can click on this, and we can see the entire deep research summary, and this one was done by OpenAI Deep Research. And for some genes, there may have been different deep research tools that are used. And if you have the time, you can look through this entire deep research summary, see if it is a good summary of what you think the gene does, and if you think it's well supported by the publications that come here. In this case, there's a mixture of database support, but also individual kind of papers here as well. So yeah, you can read as much of this if you like, and if you like the summary, and if you think it's meaningful and free of hallucinations as far as you can tell, you can give this a thumbs up too. So scrolling down, you can do this for some of the other products as well. There's also a ad hoc pathway visualization as well, where this part is a little bit more experimental, but you can feel free to take a look at that. Give this your thumbs up, thumbs down as well. If we go back up to the top, if you would like, you can give more detailed feedback on this gene by clicking on this green button. It will take you to a Google form. The key part of this form is filled in. It's already filled in with the species and the gene symbol. So you should not modify this field here. But now you can go through, and many of these individual questions are optional. So you can give as much or as little detail as you like here. You start with giving your own expertise on the gene. I'm not certainly no expert on this gene, so I might give this a 1 here. So crucially, the first question is about the original Go annotation. So again, if we go back here, this is the annotations in columns 1 and 2, and you can also look at this on the UniProt or QuickGo or AmiGo page as well. And here you can just give your overall impressions of the Go annotations. This is, quite subjective, open to interpretation, but the basic idea is you can rank between 1 and 5. If you think the original annotations were perfect, they were both accurate, there was no mistakes in them, and also they were complete. They were specific enough to be useful and they didn't miss any key functions. You can give this a 5 if you think they were perfect. But because this is a somewhat subjective system, you might want to kind of like give a little bit more justification here or describe in more detail anything that kind of like stood out for you. And again, you can be as concise as you detailed as you like here. Here you can say roughly, here we're moving on to evaluating the AI. This is roughly what percentage of the action calls. So again, this is the action plus the reasoning columns here. This is what the AI made of the original annotation. So you can indicate your agreement with these. And then you can essentially give an overall assessment over how well the AI review system performed, looking at both action and reason columns. And again, it's a simple 1 to 5 scale. So if you think the AI made the perfect calls and it made the same the same reviews that you would give, then you would give it a 5. But if you think there was even one case where the AI really completely misunderstood the biology or made a bad call, even if it did well on other annotations, if you think there was something it did horrifically, I'd encourage you to rank that as poor. You can then give your overall assessment of how well the system performed, with this star rating here. And it looks like that's a duplicate. That will be gone by the time you kind of fill this in. Sorry, it will only be the star rating here. And then again, you can, if you like, you can fill in more details here if you like. Give additional qualitative feedback. And here's where you give feedback on just the evaluation process as a whole. So not the AI review, but this kind of form-based system. Was this easy for you to complete? How long did it take you to complete? Are there things we could do to make this evaluation easier for you? And then if you like, you can enter your email so we can contact you with any further questions should you agree to that. And so thank you very much for taking a look at this, and we look forward to seeing your evaluations.